less than 1 in 100 cases, and it's probably less than 1 in 500 cases of Alzheimer's is caused by genes. The critical question is, how did we get a bigger and bigger and bigger brain and eventually become Homo sapiens? And why are our brains shrinking? When we're young and teenagers, we're learning all the time, and then you retire. Retiring itself is a big risk for dementia and Alzheimer's, unless you learn something new.
Have you ever walked into a room and completely forgotten why you went in there? Or had those afternoon slumps where your brain just feels foggy and sluggish? We usually brush these moments off as just having a busy week or getting older. But what if the food on your plate isn't just dictating your energy right now, but actually shaping your brain's health at the age of 20, 30, 40 years down the line? Welcome back to the Wellness Report. I'm Matt Maynard, and today we're unpacking how targeted nutrition can directly protect your mind, mood, and memory. Joining us is Patrick Holford, leading spokesperson on nutrition and mental health, founder of the Food for the Brain Foundation, and author of Alzheimer's Prevention is the Cure. Patrick, welcome.
Good to be back.
Brilliant. So, Patrick, let's kind of ease into general nutrition for the brain then. Most people think of diet in terms of weight or heart health, but how quickly does what we eat directly impact our daily mood, focus, and mental stamina?
Well, massively. And I mean, historically, my first study that I was involved in was one where we had a radical idea, since the brain actually consumes and uses more vitamins, minerals, essential fats than anywhere else, was what if, this was back in the very early 1980s, what if we give school children a relatively high dose multivitamin, we didn't know about essential fats then, or a placebo? Could it possibly even affect their IQ? And the idea of this, we did a pilot trial and it worked. We knew the idea of this would be very controversial. So we went out and found a professor, David Benson, from Swansea University, who thought we were nuts. There's absolutely no way that increasing vitamins and minerals is going to affect your IQ. And we had an MRC, Medical Research Council statistician. I mean, the whole study was a proper randomized placebo-controlled trial. And my sort of co-collaborator was a student of mine who was the headmaster of a secondary school. And to cut a long story short, 7 months later, we'd had a 10-point increase in the non-verbal IQ of the kids on the vitamins, a 3-point increase on the placebo. So a 7-point difference, and a 5-point difference would get half of all children classified as SEN, special educational needs, back to normal. And it hit the front page of every newspaper, it was in every news channel, and it was the first idea that what you eat affects your brain. But if we sort of go the other way around, the thing that makes us Homo sapiens unique is our brain. It's as simple as that. And what I've learned in the last 45 years of studying nutrition is that if you focus on getting the optimal level of nutrients for your brain, you will have the optimal level of nutrients for your body. And most research has really ignored brain function, like vitamin C, scurvy, whatever it happens to be. And partly because it's not so easy to measure. Now, I want to tell you one thing that is deeply significant. At the charity, foodforthebrain.org, we have a free online cognitive function test. And just to contextualize it, it's not a questionnaire, it's an interactive thing. And it's basically the digital version of what was developed and used in memory clinics around the world to diagnose someone with dementia. Because there are 4 very specific functions that start to go. One of which is the short-term memory. You walk in a room and you can't remember someone's name, or you forgot where you put your keys and so on. Now, remember, this is a test that was developed ultimately to diagnose dementia. Now, we've done about 500,000 tests now, and the cognitive function score is, on average, decreasing pretty linearly from the age of 18. In other words, a 25-year-old does worse than a 20-year-old, and a 35-year-old does worse than a 30-year-old. So this, while the extreme end is of dementia, Alzheimer's, and all the rest of it, what's becoming very, very clear is that younger people are experiencing things. They won't call it dementia, but they would brain fog, or just losing that that sharpness, not being able to concentrate for long enough, just not really connecting the dots. So this sort of forgetfulness, brain fog, etc., is affecting all of us. And if you really absorb the fact that cognitive function, which is the measure of dementia, Alzheimer's, ultimately, is basically going down from the age of 18, we can say that Alzheimer's prevention starts from the age of 18.
And that was kind of my next question, actually, Patrick, which is interesting, is when should someone start to think about, long-term brain health? At what age, is there an age that is too young to start?
Well, not really. And the other sort of big idea, which of course most people don't realize because we're never taught it, is that 6.5 million years ago, we split from gorillas, bonobos, and chimpanzees. We have effectively the same genes. They're like, tiny, tiny different. And their brain size has stayed the same, 350 grams. And over that 6.5 million years, our hominid ancestors' brains got bigger and bigger and bigger and bigger. This is all done on skull size, and peaked at around 30,000 years ago, where we have evidence of brain size of 1,690 grams, or almost 2 kilos. Today, our brain size has shrunk by 20%, and we average 1,350 grams. So the critical question is, how did we get a bigger and bigger and bigger brain and eventually become Homo sapiens? And why are our brains shrinking? So now it's a very simple thing. If you want to build a house, you got to have a hammer and some nails and some wood. You got to have all the materials. So what is it that builds a brain? And the essential neuronal membrane of a brain cell is made of 3 things. One is omega-3, DHA, which is a marine food source. We're talking sardines, herrings, anchovies, salmon, and so on. The second is something called a phospholipid, which is also rich in marine food, but it's also rich in eggs. And the third is that to put these two together, to build the brain, you have to have B vitamins, especially vitamin B12, which is not in the plant kingdom, B6, and also folate, think foliage and greens. So now to contextualize this, down the road where I live in South Wales, in the Gower Peninsula, they find a 40,000-year-old complete Homo sapiens remains. They think that it is a woman because it basically had jewelry made out of shells, a necklace of shells and so on. Turned out it was a man on DNA analysis, and it turns out that at least 20% of their diet was marine food. Now, just if you imagine, and of course this is an underestimate, that 40,000 years ago, when you had to fetch the water and fetch the wood and, hunt, gather, walk along you must have been expending double the calories through exercise. Therefore, you would eat double the calories from food. And if 20% of your food is marine food, I would have to have 40% of my diet as marine food. So from that kind of overview, we can say how much omega-3 DHA, how much phospholipids, how much B12, which is also very rich in marine food, were our ancestors getting during the period of 6 million years that led to Homo sapiens? And the answer is a hell of a lot more than we are today. So our research at foodforthebrain.org has been with a team of world-leading professors from China, America, all over the world. Professors who specialize in omega-3 or phospholipids or vitamin D or sugar or all the pieces, is what is that optimal intake? And to cut to the chase, I would say that a lack of omega-3, and I'm going to call it deficiency, which means less efficiency. So if a higher dose of omega-3 fish oil, which we need about 2 grams a day, a gram is a serving of fish. So what I'm suggesting is our ancestors were actually achieving at least a gram a day from their diet. But 2 grams versus what we get on average, which is a tenth of that, is clearly established to mean more brain volume, less risk for Alzheimer's and dementia, and better cognitive function. So anything less than that is deficient. It is lacking in efficiency. So correcting omega-3 deficiency and B vitamin deficiency, and so many people later in life don't absorb B12 very well, which is a conversation we can have, just those two will probably eliminate 40% of the risk of Alzheimer's. Just those two.
Okay. And so then what about the role of genetics then in Alzheimer's? How important do you think that it is?
Well, let's understand why this is even being considered or spoken of. There's the guy who termed Alzheimer's, Alois Alzheimer, had a patient who lost their cognitive function very rapidly, very young. We're talking in their 40s and 50s. And originally, Alzheimer's was specifically for this very early onset, rapid cognitive decline. And that does occur, but it's very, very rare. And when the ability to gene sequence came along, it was discovered that these very early onset and extremely rare cases had a variation of a gene. Now, let's explain here. What gene does is it tells your body how to put things together, put amino acids together to make proteins. And this gene related to the amyloid precursor protein. It's called APP gene. So it's to do with making something called amyloid. And if you happen to have a mutation of this gene, you make a lot more amyloid. Now, it also occurs in Down syndrome, where you also get a much more rapid and early cognitive decline. So suddenly they go, wow, we've found the cause of Alzheimer's. It's too much of this amyloid, this sticky, plucky protein that you do find in most, not all, people with Alzheimer's. So they went, that's brilliant. But there's a couple of problems here. Well, there's three, actually. The first is how many people have this APP gene mutation. And so far, there's about 500 families in the world who've been discovered to have it. So it's very, very tiny. And the second is the big push at the moment for drugs or treatment for Alzheimer's dementia is an injection of an antibody that targets amyloid and lowers it. And these drugs always end in MAB, monoclonal antibody, MAB. So we got, aducanumab, donanemab. They're all going to end in MAB, and they work in the sense that they lower amyloid. There's no question they lower the amount of amyloid in the brain. But not a single one of them has yet produced a clinically significant effect. In other words, one that the sufferer, the carer, the spouse would actually notice at a cost of, about 50 grand a year. Now, but there's one more very, very, very important question. And that is to ask, well, why are we genetically designed to produce this seemingly toxic amyloid stuff? And now what happens is if you do a brain scan of anyone with any kind of dementia, you will find evidence of at least 1,000 bleeds, points of bleed. There's a way to scan the brain and you can see these little dots, which are places where a microbleed has occurred. A stroke is a big bleed. We're talking about tiny little bleeds. I mean, it could even be, I watched the World Cup, FIFA. And I watch these guys doing these incredible, with their head. I think that's probably going to produce a point of bleed. Is the reality. But someone with dementia has 1,000 of them. And then there's a way to scan the brain to see where the amyloid is. And the answer is, it's exactly the same. Every single bleed point, you will find amyloid. So what we now realize is that the brain is like an electrical circuit and blood is a bit like water. You cannot get blood into the brain. It's terrible. It will short circuit things, which is what a stroke is. Also, you can get infection into the brain. So we hear about things like herpes, not brushing your teeth. There's something called P. gingivalis. So amyloid is the evolutionary essential design that we have to stop a bleed. So then if you go back to these drug treatments that lower amyloid, what's the side effect? Well, the answer is almost a quarter get bleeding. So the amyloid is like a plaster that stops a bleed, and the drug removes the amyloid, and then you bleed. So it's a wonderful example of totally missing the fundamental question, which is what causes that. So back to your original question, we can say categorically that less than 1 in 100 cases, and it's probably less than 1 in 500 cases, of Alzheimer's is caused by genes.
Right. Okay. You sort of discussed how vitamins and omega-3 work together as a team. What about if a person in the modern world was eating their high sugar, refined carb diet? How does that affect and starve the brain of energy?
Well, in my book, and by the way, there's a lovely quote here from one of America's leading neurologists, 5 times New York Times bestseller. Becoming an Alzheimer's patient is almost always a choice. This book explains why. And the point of the almost is that for those very, very small genetic, it's going to happen. And choice, if you knew what to do, it's a choice. Most people don't. And in the book, what's very clear is of the 30 or 40 known risk factors, from smoking to exercise to hearing loss to whatever, which seem to be, it's a list that will be growing. If you just think that structure, function, utilization, and it's kind of the same with anything. It's like your car has pieces. That's the structure. The pieces have to work. You've then got function. So for that, you need fuel. And whenever you have fuel, you have exhaust fumes. The brain is incredibly, every single thought and feeling and sight and sound is generating energy. So the brain is by far the most energy intensive organ. And all that energy, which is made from 2 fuels, one is glucose, think sugar, and the other is ketones, which are made in the liver from fat. I'll talk about that in a minute. Will generate oxidants, exhaust fumes. And so on the one hand, for the structure, we need the omega-3 and we need the phospholipids and we need the B vitamins to put it together. For function, we need a steady, even supply of fuel plus the antidote, the antioxidants. Now, what happens is the more sugar a person eats, and the ultra-processed foods and refined food and so on, whenever your blood glucose goes up, the body makes something called insulin, a hormone, which takes the sugar out of the blood into cells so they can use it and takes the excess to the liver where it turns it into fat. So sugar makes you fat in excess. And the more often you eat sugar and sugary foods, the more insulin you produce. And in time, you become deaf to the effects of insulin, which is called insulin resistance. So now those brain cells, and just to put it into context, you've got in your total 100,000 miles of blood vessels in your body, you've got less than a teaspoon of glucose. You've got about 4 grams of glucose. And then if you drink a can of Coke, you're getting like 10 to 20 grams. So it's terribly easy to go beyond what you need. And when you do, you become insulin resistant. When you become insulin resistant, now you can't get fuel into the brain. So you experience brain fog. And your system tells you what you need is sugar. So if on the one hand, you're experiencing loss of concentration, loss of mental energy, brain fog, just nothing's clicking. And on the other hand, you have a desire to eat something sweet, then you're in the zone of insulin resistance. So the recent study showed that those with what we call metabolic syndrome, which is this thing, insulin resistance, have a 24% increased risk of developing young onset dementia. So now we've got the omega-3s and the B vitamins and that area. Let's say it's about 40% of risk. Too much sugar is, 20 to 25% of risk. And then you've got the antioxidants. So smoking, for example, is an oxidant. So smoking increases risk, no question about that. Increasing antioxidants from fruit and veg and things like vitamin C and vitamin E, etc., reduce risk. So let's give the antioxidants about, a 10% role. And, if sugar is 25% and the B vitamins are 40%, we're now up to about 70% of the risk of Alzheimer's is to do with omega-3s, B vitamins, phospholipids as well, sugar, and a lack of antioxidants or generating more, such as smoking.
Beyond nutrition, women account for nearly 2/3 of Alzheimer's diagnoses.
Mm-hmm.
What role do hormones, chronic stress, and sleep play in helping the brain clean and repair itself overnight?
Well, first of all, let's look at what a lack of sleep or poor sleep and what stress does to the brain. We all have an adrenal system that is designed to crank us up in a moment where we need to run fast, act fast. It's called the fight-flight syndrome. And in those periods of time of high adrenaline, the body, our system, puts all the energy into survival and stops other basic functions like digestion. It's not important. You're running for your life. Anti-aging repair processes, not important. You're trying to stay alive. And that's what it does. And then very quickly you recover. Now, funny enough, I'm 68 and I decided when I was 65 I should learn something new. This is the big mistake that people make. When we're young and teenagers, we're learning all the time, and then you retire. Retiring itself is a big risk for dementia and Alzheimer's unless you learn something new. So I decided I'm going to take up paragliding. And a friend of mine gave me one of these little digital watches. And it's really interesting because here my pulse is cruising along between 60 and 70 most of the time. That's what it is now. And then I noticed when I jumped off the mountain the other day, it goes up to 150, It's quite stressful. But then I recover. So if you are permanently in a state of anxiety and stress and you don't recover, it actually starts to shrink an area of the brain. It's like you've got the brakes on and the accelerator at the same time. So that's why stress is bad. The next thing is that sleep is a total essential of every single oxygen-based life form mammal. All mammals sleep because after that intense period of a day, when the brain is generating so much energy, it needs to recover. So sleep is part of that recovery. So if you don't get enough sleep or enough good quality sleep, your brain does not recover. So that is why too much stress, anxiety, and lack of sleep are bad for you. Then back to your question, why are women more at risk of Alzheimer's and dementia? And I believe there's a very simple reason for this. You may or may not know, but there are only 5 species in the world that have a menopause. The vast majority of animals have no menopause, but we do, or women do. And when a woman hits the menopause, they stop producing the hormone progesterone, from which they make estrogen. Now, why is that relevant? Well, progesterone switches off adrenaline. So if, let's assume already you were quite anxious, quite stressed, quite not the best sleeper, and then you hit the menopause and your progesterone level crashes, it's going to absolutely crank up adrenaline. And we've learned why that is bad. So conversely, what has become very clear now is that progesterone, from which we make estrogen, and the estrogens and testosterone, also made from progesterone, are actually neuroregenerative. They help to make new connections and new brain cells. So in a sense, it's a very interesting thing because vitamin D is not a vitamin. It's a hormone. It has to, sunlight acts on our skin, and we turn cholesterol into a hormone. And even if you supplement what is called vitamin D, it actually has to be turned into a hormone. And we have learned that we are all deficient in the hormone vitamin D between October and March, because the angle of the sun is not sufficient. So everyone kind of gets that. But for some reason, there are a lot of people do not get that every woman postmenopausally is deficient in progesterone. And therefore, there is a very big movement, and it's backed by some extremely good science, to say that postmenopausal women should supplement progesterone, possibly estrogen, possibly testosterone, at the level that they produce premenopausally, in the same way that we say everyone should supplement vitamin D during the winter at the amount that allows our blood level to be the same that it would be, in the sunnier months. It's the same thing. So definitely that's a contributory factor. I'm going to, maybe put 10% on that as a number for women. But men also can be low in hormones too. But it is crazy that I'm actually producing more estrogen as a man than my wife. Yeah. Because she's postmenopausal.
We haven't got too much longer, Patrick, so I kind of want to give people a takeaway message from you, really. And if someone was watching today and wants to start protecting their cognitive health immediately, what are the top 3 simple dietary or supplement additions that they should be making tomorrow?
Okay, so for structure, we said up your omega-3s, have enough B vitamins, and there's a blood test called homocysteine, which determines if you have enough. It's very important. Everyone should do that over 50. Eat phospholipids, which means eggs. So we're into fish and eggs and whole foods and B vitamins. That's on the structure. On the function, much less sugar and carbohydrates, increase antioxidants. We're talking fruit and veg. Supplement vitamin C is very, very helpful. And then the last part we didn't fully cover, but we've touched on, is utilization. You've got to use your brain. So you want an active lifestyle, physically active, at least, let's say, 7, 8, 9, 10,000 steps a day. Use your mind, learn new things, and then, get the book, because it's very, very clear. And this book, by the way, has become the strategy in China for preventing Alzheimer's. And go to foodforthebrain.org, where you can actually measure how you are now. So you've now got a baseline of how you are. Fill in the questionnaire, and it will tell you what your risk is. And then they even have a blood test at the charity. You send for a kit. It's called the Drift Test, and it will measure your sugar level, your omega level, your vitamin D, your homocysteine for the B vitamins, and your antioxidant status. One single prick of blood, and now you have the biology of telling you what's going on. So you now have an action plan. From your diet and lifestyle, they'll tell you focus on this. From your blood, they will say focus on this. And that is why the book is called Alzheimer's Prevention is the Cure. Nobody needs to lose their mind. Their hair might go grey, that happens, but you do not need to lose your mind at any age.
Brilliant. Thank you so much, Patrick.
My pleasure.